All right, so here's a quick video on adding fractions. We're going to look at all the sort of different situations for grade 8 and some different models you could use that actually show how they work instead of just tricks. So we're going to start with 3/8 plus 2/8. And this is generally an easier one because we're just adding 8s and 8s, and kids can quickly learn that that's 5/8. You know, and you can think about it, 3 meters plus 2 meters is 5 meters, 3 oranges plus 2 oranges is 5 oranges, whatever, 3 somethings plus 2 somethings is 5 of those things. So that becomes pretty easy. Okay, fraction squares are big. So if I make a square, or that looks like more of a rectangle, but same idea, and then I split it up into 8s, like that, then you could easily sort of model this by showing, well, here's 3/8, and if I'm going to add 2 more, then I can add those 2, for example, and that shows me my 5/8 because I got 1, 2, 3, 4, 5 out of 8. Okay, so that's usually pretty easy for kids in grade 8. A second sort of model you could use would be a number line. So all fractions that are proper, in this case a lower number as the numerator and a larger number as the denominator, exists between 0 and 1, so that's my number line. Of course, numbers go on forever in both directions. But anyways, I can split this up in half-ish, and that would be 4/8, right? And then this would be 6/8, and a whole would be 8/8. This would be 0/8, 2/8, oops. And I could fill in, the missing numbers if needed. So since this story starts at 3/8, I can put a little dot there, and there it is at 3/8. And if I need to add 2 more, I'm going to need my 5/8 here. Because if I need to add 2 more 8s, so 3/8 plus 2/8, so I'm jumping ahead 1/8 and jumping ahead another 1/8, and there I am at 5/8. So that's a number line. So there's 2 models that both work very well. And you could also use fraction strips. Fraction strips are generally difficult to use because they need to sort of be perfectly measured, especially if you're not adding 8s plus 8s, but you're adding 8s plus 5ths or something like that. So I don't really like fraction strips. I like them. They're great if you have them, but if you don't or you're trying to draw them, I find them very difficult, so I'm not going to do that. I have one more model that I'm going to show you for a different type of question. So there we go. Okay. Now things get a little bit trickier when we have something like, let's stick with 8s. 5/8 plus, let's say, 7/8. So we can sort of use our idea of, meters or oranges. So 5/8 plus 7/8, well, that's 5 somethings plus 7 somethings, and that's going to give us 12 somethings, in this case 8. So that's like the answer, and that's fine. But as for a model, again, we could do a fraction square here, where we start with 5/8, so 1, 2, 3, 4, 5, and now we need to add on 7/8, so I add on 1, 2, 3, right, I'm out of room, so I need a second whole to start filling up, and I was at 3, I needed 7, so 1, 2, 3, 4, 5, 6, 7. And then I can quickly see how many 8s do I have. Well, I got 1, 2, 3, 4 8s, 5, 6, 7, 8 8s, 9, 10, 11, 12, 12 8s. So there's my proof. Okay, number line again, same idea. Start at 0. Now this time I know I'm going to need to go over 1, but let's pretend I didn't and I only went to 1. And here's 4 8s, and here's 6. Oops. 6 8s, so 5 8s would be here. And here's 7 8s, and the whole would be 8. Oops. 8 8s. So if I start at 5 8s and I need to add 7 8s, well, I'm adding 1, I'm adding 2, I'm adding 3. Right? I've ran out of room. So I need to go 9 8s, 10 8s, 11 8s, 12 8s, and I could go on forever and ever and ever. But I've gone 1, 2, 3. I need to go 7, so 4, 5, 6, 7, and there I am at 12 8s. So another model that proves it as well. Okay, so that one's a little bit trickier because we end up with an improper fraction, 12 8s, or we could make a mixed number of 1 and 4 8s, which is 1 and a half, etc., etc., etc. Okay, so that's adding when we end up with more than one whole. So things get a little bit tricky, but still, not bad. There's my whole, and I've gone well past it. Okay, so let's do a little bit trickier question now. So 1 quarter, 1/4, plus 2/3. So this one is obviously going to be a little trickier. No longer just adding, eighths that were the same. We're now adding quarters plus thirds. So things here get a little bit trickier. So when I was a kid, the model we were taught was find a common denominator. So we've got 4 and 3. So I think, well, what do they both go into? What are they both a factor of? And I could just say, well, 4 times 3 is 12. So I know they both go into 12. And that's low enough to work. So let's go with it. Sometimes there might be other answers that are lower. But you can always just multiply to get a for sure answer, even though it might be large. Now 12 is nice, not too bad to work with. So how do I go from 1/4 to 12ths? Well, I need to multiply that by 3 because I'm multiplying 4 times 3 to get to 12. And if 1/4 times 3 is going to give me 3/12 because I multiply the numerator and the denominator by the same number, and that's what I get. Okay. Second one, I also want to make 12s. Well, that one I need to multiply by 4. And that's going to give me 8/12. Okay, so this is how I was taught. And it was never really sort of explained to me. It was just, here it is. Here's a bunch of questions, right? So that works, and now we can do the simple adding to get 11/12. Great, okay? But that's still not a model. I'm not really convinced, right? I mean, okay, I get it. I'm trying to make it be like these questions that had all eighths because they were pretty easy once I got the hang of it. So if I make them both 12s, well, now it's easier, right? But I'm not really 100% convinced. So if I try my fraction squares strategy, I'm not quite sure how to do it, because if I start off with 1/4, okay, but then I need to add 2/3. Well, does that look like that, or do I color in 2/3 here and it ends up I'm not quite clear on how to do that. I can see that it looks like I'm going to be I'm going to be close to a whole, but it's not clear. So fraction squares sort of fall apart when you have different denominators. They're not as convincing. So I could try the number line as well, but I might run into the same sort of problem where if I'm starting at 1/4, well, that's not too bad because there's a half, or I should probably write 2/4, right? And then here's 1/4, and I'm starting there, but then I'm adding on thirds, so I'd have to split it again with, this is 1/3, I guess, and this is 2/3, and you can see where I start to run into problems with how I'm going to add those together, and all of a sudden, this sort of messy work where I just sort of had, lines that were approximately the same distance. Now do I need a ruler? Things get crazy, right? So I don't love these two models for a question like this where we have different denominators. But what I do love is a model that looks like this. So since my denominators are 4 and 3, I'm going to actually build an array, okay, 4x3 grid. So I'm going to put my 4 on this side. It doesn't matter, the 4 could be on the top. And I'm going to split this in 2/3. So it looks like that. I've gone a little bit over, no worries. Get out of here. Okay, so this is 4x3. So you might have noticed now I have 12 grid spaces, which is exactly the same thing I ended up with in the version that I did, the algorithm that I used as a kid. But I hope this will make a little more sense. So now I start with 1/4. Okay, so what does that look like in my box? Well, I've split my box here, my grid, into 4 parts this way. So 1 column, 2 column, 3 columns, 4 columns. So if I want to fill up one of those columns, I would just go ahead and do that. And it would look something like this. I could shade them in. I'm going to use dots this time, but whatever works for you. Okay, so I've filled in 1/4 of this box, and I think it looks like that. Now I know we're used to seeing 1/4 sort of looking like this, but it's really the same area that I'm taking up. I'm taking up 1 out of 4 boxes. I'm taking up 1 out of 4 rows. So that's my 1/4. I've modeled it with red there, okay? I'll switch back to blue here for the 2/3. So now my problem is I need to fill 2/3. So I would like to fill 2 out of the 3 columns, this column and this column. But my problem is that there are dots in those. So I need to find a new home for these dots. And I'm going to just sort of move them from here to here. So if I was using a pencil, I could erase them or whatever. I'm just going to cross them out so I remember that they're not there anymore. And I've sort of readjusted where they're placed, okay? And it still makes sense. It's still 1/4 because I filled up these 3 boxes instead of these 3 boxes. So we know that was a quarter before. So it's still a quarter. I've just changed the arrangement, okay? So now to add on my 2/3. I want to add 2/3. So that would be 2 columns out of the 3 columns. And that is 2/3. So all of this is filled in. All of this is filled in. And this is filled in. So how much did we end up filling in when we added the quarter plus the 2/3? Well, we ended up filling up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 boxes out of a total of 12 boxes. So we got the same answer I got as a kid with the algorithm I was taught. However, I think this models it much better. So we made an array using the 2 denominators, 4 by 3. You know, if this was 1/7 and 1/3, then we would use 7 by 3, make a 21 grid instead, or an array. So I hope you like that model. I think it's fairly clear, and you can go into sort of larger numbers, right? Like if I had to add, let's say like a whole and 2/3 plus 3 and let's say a 5th, I could still use this model because I could say, well, the 3 and the 1 wholes together are going to give me a 4, so I'll keep that off to the side. And now I just need to add the 2/3 and the 1/5, and so I would make my grid system here, and I'm going to make it 3 that way, and I'm going to make it 5 down. So I'll write my 3 there so don't forget, that's one denominator. And then 1, 2, 3, 4, 5, and I'll just finish my grid. And there it is, 15 boxes. So my 2/3 are going to be all of these, right? 2 out of the 3 rows are now full. So I did that in blue. And now I need to do just 1/5. So out of these 5 columns, I just need to color 1. So I've got these 2 guys in the way. Move them out. Put them over here. And now I can fill in my 1/5, and it looks like that. So by the time I'm done adding my 2/3 and my 1/5, I've used out of these 15 boxes, right? Because there was 5, 10, 15. I've used 3, 6, 7, 8, 9, 10, 13. So I've used 13/15. So the answer to this question of 1 and 2/3 plus 3 and 1/5 is 4 and 13/15. Okay, and there's the proof there in the array model. Pretty cool.